made a few updates to our spec with the intent of implementing them, of course. So I've actually spent some time working on that. The first thing that we did is implement support for JSON type, language specification types. And under types, we should have JSON type. And I think this is a really interesting example of where Wing can be, of where we can actually, of what does it mean to be a cloud-oriented language, a language designed for the cloud, not related to resources or in-flights. We've been talking a lot about resources and in-flights because there are the fundamental building blocks of the cloud. But JSON is another really interesting example because the cloud, JSON is definitely the data format protocol of the cloud, and every cloud application deals a lot with JSON. And so we believe that being able to actually work with JSON in a native way in Wing and in a safe way in Wing is something that the language can shine in. And one really cool example of that is the safety that we can offer. And so this quick example can demonstrate it. So what we're seeing here is, let's say we have this function or method called HTTP get, and it retrieves an employee's object. So it looks like this: items, and then employee, 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 employee. And what we're doing here, and then we have this struct, Wing struct, that represents a single employee. And every employee is an ID and name. That's basically the data. That's basically the data type inside each item. And what we're doing here is we're basically retrieving a JSON object, right? Like a JSON response. And we're using the from JSON method that exists an array of type T to convert the JSON response, the items, into an employee's object. And then this employee's object is a strongly typed Wing first-class citizen array. And now I can go and iterate on that array and print the name and print the ID. That's actually needs to be e.id. What's this? I think it's a good read because I think it's starting to demonstrate some of the power of Wing as a cloud-oriented language. Again, on a different area of like handling JSON in a safe way. And I think it's also an interesting area in terms of language design, because one of the things that JavaScript specifically and TypeScript are very good at is the fact that JSON is a native JavaScript. Then JSON and JavaScript has this very, very strong connection. And I think it has both pros and cons, this strong connection, because JSON by nature is untyped, is very dynamic, and that dynamic nature is carried over into the runtime. It's carried over into the programming language. It's carried over into the TypeScript type system in the form of structural typing and union types and a lot of complexity that comes with it. And what we're trying to do is we're trying to say, well, we want Wing to be a great application development or service development programming language. We want it to be strongly typed, statically typed, safe. And there's this impedance mismatch between the concepts of JSON and that concept. And so but we don't want to carry over all of the complexity and the lack of safety that comes with that complexity into the language. We want to make sure that we have this clear boundary that says, until here we're unsafe, and from this point over we are moving into a type safe area. And so one of the things that we have in Wing, which I think is an interesting thing to continue to explore, is this concept of from JSON, right? When I take a JSON object like this, and it contains a string, I can't really assign it to a string in a safe way, because I don't know, as a JSON object, it could be a string, it could be a number, it could be an array, it could be an object, it could be anything. And so in Wing, we actually have to be explicit about moving from the unsafe world to the safe world. And currently, we're thinking of doing this through this set of methods called from JSON. And so if you want to take this J and convert it to a string, you need to do str from JSON J, and then you get a strongly typed string. And the thing is that as you call these from JSON methods, it performs schema validation. It basically makes sure that the value, the actual runtime value, is what you expect it to be, which means that after you've finished this conversion, you are now in the safe space. You're now in this, yes, I'm here. You're now in a statically typed and safe programming space. And this applies to primitives and collection. It also applies to structs. So you can actually do contact. In this case, I have a contact first last phone, and I can do contact from JSON, and then I just basically get a strongly typed version of contact. And it's strongly typed, and it's guaranteed to actually be correct, which is something that, for example, in TypeScript is actually pretty hard to do. Right? In TypeScript, you define this as an interface, and you can say, well, I want to look at this object with these lens, with this view, but there's no guarantee that that's going to be the actual reality, right? Like there could be a completely different structure behind that object, and only at runtime I will know that. Only in runtime I will basically won't be able to dereference something or treat something as a string or a number or an object. And so this is an interesting kind of portal into the safety of the type system, and we'll see what it entails. You can also opt out from that if you want. Probably not going to be something we support initially, but you can say unsafe true, which basically says, I'm in TypeScript mode now, and you can just basically look at this as if it was because underlying we have JavaScript, and so eventually we are compiling to a dynamic language. But we want to make sure that even though we're compiling to a dynamic language, the language is statically typed and the safety is statically guaranteed. So that's a really interesting kind of like language design conversation that we've been having in Wing.